empty here. Project 2 is basically a upgrade of Project 1. So Project 1 we had just this kind of simple, in the default project we had like a simple painting app. Project 2 is a bit more involved. Here's an example. So you still have the painting. You can change the type of painting. You can actually clear the paint and get the particle effect. You can also change the size of the painting. Let's see, size. So we're going to cover some of these features today just so you may use it in your project somehow. There's also a glow kind of option and opacity option, so all of this is kind of cool. Time of day option, mouse position option. So we already did a lot of these things, but we're just adding more layers here. If you look at the syllabus, you can see, okay, where are we? Yeah, so the project 2 is due October 21st. It's also an assignment on Canvas. And there also may be a quiz next week. So according to the syllabus, we're due for a week for a quiz next week. So I'm going to send a reminder for that, if it happens indeed next week or not. But you should just be ready to prepare. Any questions? Any questions? This is just the syllabus. You can access this on the website over here. Syllabus here. Okay, just access it over here. And also, project 2 is right here. So project 2, just to remind you, is same drill as you had with project 1, but you need 4 user flows this time around. And one remark about project 1 is some people have used the ideation kind of to actually figure out if their ideas are good or bad, which is great. We want you to use ideation. But some people have actually implemented something else they didn't write about. So they said, for example, oh, I want to implement a soccer whatever UI game, but they ended up doing, I don't know, like a storm weather game or something. So yeah, so if you commit to something, do it. Otherwise, we'll be in a kind of a bit of a trick kind of place on how to grade you, okay? Because maybe your assignment is not approved. Maybe you did something it's like not really user flow that's approved by us. So don't if you commit to something in ideation, you do that. Same thing with project 2. So project 2 also has ideation over here. Project 2 design. So you're supposed to complete it all, okay? Any questions on that? No? Okay, good. So last week, what did we do last week? So let's go to Unity and check it out. So last week, okay, let me cancel this quad for a second. So we still had our painting app. We did have kind of some color control. We can basically change the color. The color is not super randomized. It's kind of the same color. It's not what you get here in this, but we can talk about how to do that. That's not a big difference. Yeah, we also have this mouse XY kind of highlight that tells you where your mouse is on the screen. We also talked about how to change the type of shape you're painting. We also had the this kind of destroy everything function, which destroys everything. And what else? We also have this kind of this slider that basically just decides the distance on where to paint something. So for example, if let me click. This is like super close, but I can just make it a bit far, and let me try to paint again. That will be a bit far. Okay, so what I would like to do is I would just like to go slowly over the features here in this app. So in this example app, if you click on clear, you get this particle effect. So I want to implement that first. that's not too big of a deal. So and this is recorded, by the way, so you can watch at home later if you're not following. So if you go, let's go to our. That's not it. Yeah. So let's stop this and deactivate this quad for a second. And what I want to do now is I want to add like a particle system. Basically, I want to add this kind of effect to my UI. So to do that, I need to right-click here. And here there is an option somewhere called particle system. Let's see where it is. Effects. It's under effects. So particle system. Okay. Now once you add this particle system, it's pretty cool. You get this kind of continuously playing kind of almost kind of smoky effect. And you can also see this here on the game screen, which is nice. You can also stop it if it's kind of annoying you or playing it, but we're just gonna let it be for a second. So to get everything to work right without any kind of issues, I want first of all to kind of zero out all this transform positions. A lot of the times, like if you have some drama happening with your code and things are not popping out the way they should be, it's because of the coordinate systems here. So let's just make everything 0. Rotation 0 too if we can. Yeah, or we can just leave it 90. 90 is okay. And now with this being correct, let's use this somehow when the objects are destroyed. So here when I have this drawing and I click clear, I get this kind of cool particle system effect. So the way to get that working, and let's close this. So the way to get that working is always having something in your script doing that for us. So let's go to our scripts, painting. Okay, let's wait for it to load. Are you loading? Yes, no. You're just loading slow. So okay, so now what I want to do is I want to connect this example particle system that I have here that's doing this kind of funky effect to my code somehow. So I'm going to just do it the normal way we're going to do everything. I'm going to introduce some sort of variable here that captures that and kind of link the script to that particle system. So I'm just going to do public particle system, okay, particle system. Okay, now this is just going to be a placeholder to link some particle system to my code. So let's save this. And if I save it, you should see that kind of progress bar. And now let's go on to Click Manager, and I should have like a placeholder here for particle system. So I'm going to drag this particle system over here. Okay, and now it's kind of linked to my code. So the next step, like if you look here at the code, the effect that I want to have, this is the demo app. So the effect that I want to have is this kind of particle system kind of popping up every time I destroy an object. And then after, like I say, 2 seconds, it disappears, okay? That's basically the logic. So it pops up, and then like after a second or 2, disappears. So what I should do here, basically, in my code, I should look to where just to remind you, in my code here, I have this destroy everything button, right? So let's just see what that does again. Destroy everything, destroy button. You can see the destroy button is connected to a function called destroy everything, okay? So I can go to destroy everything. Oh, it's right here actually. So this is my destroy everything function, and what it does right now, it just iterates over all of the children of the current kind of object associated with the script, and then calls destroy. Okay. So to clear this up, let's kind of do something like this. So we want to basically instantiate a particle system every time we are destroying an object. So let's do particle system, let's particles equals instantiate, and this will be our particle system. So basically, I'm using this linked particle system as a template to my instantiated particle system. Okay, now there's going to be a bug. If I play this, and let's make this a bit bigger, and I click destroy everything, what happened? If I create these objects, okay, and I click destroy everything, I'm not getting what I want, right?
Yeah.
What's wrong?
It's not
It's putting here all, yeah. So the problem is they're instantiated in the wrong place. I need to put them in the right place. The right place is the coordinates of all of these kind of paintable objects, okay? So let's go back to the code, and a quick fix here is particles dot transform dot position equals this child transform. So this is the child game object. Child position. So I'm basically just form. So what I'm going to do is I'm going to assign the position of that object I'm destroying to particles, this essentially particle system. I also want to destroy it, remember, because it evaporates after a while. So we're going to just call destroy, destroy particles, and this, just to remind you, accepts a couple of. It can either accept like no, just the game object you're destroying, or it can accept some sort of additional input, which is the number of seconds after which it will destroy that object. So I'm just going to say here that to destroy the particles after 2 seconds. So let's save this and go here and click play. Okay, so I'm creating this stuff. Let's destroy, and you get this cool effect. Okay, that was not too hard, right? Any questions on that? No? Okay. So one thing that may be slightly annoying is I have this original particle system that's still kind of playing here in the background, which is a little bit trippy. I may just want to disable it, okay, when it's like when we start the app, because I don't really need it anymore. I only need it to do that its thing when I destroy the object. So a way to do that is if you go to the code, and remember we have this particle system kind of placeholder. So I'm just going to disable it. Let me see how to do that. So I'm going to do this particle system, and let's see if there's a way to disable it. I think it's called pause, maybe. Okay, so so what this does here, it says pauses the system so no new particles are emitted and the existing particles are not updated. So you really sometimes have to dig into the API to see, because it's different for each kind of object. Now let's see if this works. I checked this at home, so this should work, but let's just check. If I play, okay, so if I play, that kind of initial particle system is not doing its emissions anymore, so it looks like it's good. Okay, so what I wanted you to all to do is actually implement this on your own right now because it's a very easy thing to implement. You see, I only had to kind of instantiate the system and basically destroy it after that. So take the next 5 minutes to just go over this and try to implement. As you're implementing this, I want to just point out that you can actually do all kinds of modifications to the particle system. So you don't have to use like a white kind of color. You can actually change the color to be yellow or whatever you want it to be. For example, you can also change the all kinds of other parameters here. You can change the start delay, start lifetime, start speed. I can make it twice as fast, for example. All kinds of kind of funny things. Or you can make it just super slow. Here's an example. Let's just see what happens if I try these settings. Yeah, so it's like, whatever you want it to be. You don't have to be stuck with the default settings. So we're almost out of time. Any questions here? Okay, so it looks like most of you are kind of don't have any questions on this. So what I want to let's go back to this demo app, and here you can see just to remind you here we did this feature, this particle feature. Now let's look over the other features here. So there's like this size slider that does this effect. Basically, if you have any objects that you painted, they are basically, you can rescale them kind of on the go, which is kind of nifty, like this. So you can make all of them kind of either grow large or small, as in this kind of example. So let's work on that. But before I do that, let's do some house cleaning. So just to remind you, we have all these options going on here in the UI. We have the red, green, blue. So I just want to remind you, you don't have to use the default kind of settings. You can actually kind of play around with them. So here, and this is something that should show up on your side too. So this painting, red, green, blue, is kind of large. These kind of buttons that I'm using as a label. So what I want to do now, before I kind of add a new slider, I just want to clean this up a little bit. So let's see. So I have this, what is this? First of all, let's just zoom in on the slider. Okay, so this slider, let's just put way up here so it doesn't bother us. Let's just put it up there and figure out what to do with it later. And now let's focus on this red, green, and blue sliders and just make them a bit prettier. So just to remind you, you have access to change the size of the button here. So you can actually use this environment, but you can also just change it like here. So I'm just gonna make it a bit skinny because I'm just gonna. Why am I doing this? Because I'm soon gonna overload this with 3 more sliders and buttons and all of that. So I just want to make it smaller so I have space for more of my stuff. So let's see, maybe we can get along with 60, and let's make this 62, and let's make this 62. Okay, that's kind of small, that's good. Now let's move these guys. I'm just going to select all of them and move them together like this. So now these sliders, if you look at them, are kind of aesthetically, they're like okay, but they don't really need to be that big. They can be smaller. So let's also aesthetically kind of do a house cleaning over there. So let's just make them a bit smaller. So let's make it 60. Maybe let's make this 62. It doesn't have to be 60 on your side. It just whatever looks kind of okay for me over here. And now we have all this kind of blank space, which is not really pretty in any way. So I want to condense things a bit more. So let's again select these three with a shift, and just move it like this. And let's again move these guys all the way here. And now I have space for another 3 slides over here. Okay. So let's save this. And create those sliders. So before I do create those sliders, again, what I'm trying to do is, let's cancel, I don't know what it is. So what I'm trying to do, I have these size, glow, and opacity sliders, okay? So I want to, first of all, work on the size slider. That's kind of not too difficult to understand. So I'm basically making space for these sliders in my app. So that's why I did this house cleaning, which is kind of important. Now I want to do a little bit more house cleaning because I'm gonna like reuse this style. What I want to do is just want to copy paste this so I can reuse it wherever I am. So if you look here in this inspector, you can see the red color slider is kind of separate from the red label. So I'm gonna bring it like to be under it, okay? So I basically made this red color, red label, this button, like a child of this slider. So now if I kind of copy this slider, kind of duplicate it, I can just get this button for free, okay? That's why I did that. So let's place it somewhere here, I guess here. And like now that we have this, we actually need to change its name. Let's change it to be size slider. And that should be, instead of the red label, it should be size label. Okay. So I'm just trying to be consistent here so it's easier for me to debug. And I actually also want to change that text here to not say red, to say size. And I actually also want to change the color here of this to be something more neutral, so I'm not confused when I'm kind of working on this later on. So let's make it like that. Any questions on these house cleaning ops? So this is something you should probably do every time you're introducing new sliders, new features, just clean it up a little bit. Okay, so we have this size slider. Good. Now let's get this feature to work. So let's look at this feature again. So here, this is the demo app. So here, I every time I paint some objects here, I can basically resize them on the go, like this. Okay. So let's figure out what's happening here. So this slider, what it does, it basically goes to visits each object that I have here, and it basically multiplies its size by some sort of number. You know, this could be, for example, 5, and this could be like 0.1. So that's basically the number I'm multiplying it. So, you know, if I multiply by 5, that'll be the largest. If it's like 0.1, that'll be the smallest, for example. So I already have in my code logic that does something like that, and that's this for each logic. So this for each logic, just to remind you, what it does, it iterates over all these objects that I paint in my code. Like, for example, I'm painting these objects, and it destroys them. So it really does that. So I'm going to reuse that logic, so it's more convenient, so I don't have to reinvent the wheel here. So that's what I'm going to do. But before that, let me actually create like some sort of function here that kind of is gonna like link to this slider. So right now this slider doesn't have a designated function, so I need to actually create that. So let's create that function first. So let's create a function called public void set size. Okay, and it will get a float because the slider is a float size. Okay. And now we can save this. It's not going to do anything. I'm just going to connect it, first of all. So now if you go to the size slider over here, this slider over here, we want to get it to call that function we just created. So we go here to painting and set size. And now everything should be kind of linked together. Now if you don't believe me and if you don't believe yourself, you can just add a print log size slider moved. Okay, and this will be, I'm just printing out, you know, the value. Now this we should be treat with care here because this slider is a bit finicky. I'm going to explain why in a second. Okay, so let's play this. And as I'm moving, I can see this size slider moved kind of, and I can get these prints, so everything is kind of well. Any questions so far? Okay. So now, before I actually put down code there that does the modifications, let's look at the size slider. So right now, and this is kind of important, so the size slider kind of moves right now between two values, between 0 and 1, okay? So 0 basically means if you scale it by 0, that means that you're going to get the object to shrink to like a point, which is, I guess, theoretically possible, but not really good for a painting app because you actually want it to be somewhat visible. So I'm going to change this to be like, say, a 0.1 or something like that. So it's going to be barely kind of viewable, okay? Because we don't really want it to be that small. It's not going to help us. It's a painting app in the end of the day. It's not like a theoretical device for scaling. And the maximum value of 1 doesn't also really make sense because remember, this is like a number you're going to multiply your size by. So if you're multiply, like if your size by 1, it doesn't really do anything. Like 5 times 1 stays 5, right? So you want to have it a number like larger than 1. So let's, for the sake of the example, let's make it 3, okay? Now, another tricky thing you need to pay attention to is the default value of the slider. So right now, the default value is 0.5. So by default, it will shrink things by 0.5. So by default, it will shrink things by half. So I'm thinking that maybe that's too much, kind of like, you know, out of the blue, kind of sudden. So because when the user is going to touch this slider, it will immediately shrink it to by half. So you want it to be more gradual. So just set it to be 1. So it's just going to default to the same size, and the user can have freedom to play around with it, like, you know, as it's shrinking or increasing or whatever. So let's just save that so far. So that's basically. So these values are kind of important. You have to kind of fiddle with them to get them to be the right ones that are going to work with your code. Okay, so so now what I said is we're going to use this loop to ease our way into kind of changing the size of all these guys. So let's just copy this here. And let's delete all the non-relevant stuff. Actually, this is relevant. Okay. So what I want to do is I want to do child transform dot scale, local scale. So local scale is a vector, right? It's a vector of 3 components. Why it has 3 components? Because if you go to your, let's go to this cylinder guy. If you go to this cylinder over here, this cylinder here, that's moving. It has like 3 scale values. It has a scale value for X, Y, and Z. So you can change each of these, you know, as you see fit. You can make it skinnier or not as skinny and so on. So it doesn't matter. You can do whatever you want. But that's why we need, like, when we're changing the scale, we need to change 3 values, or we need to define its 3 values. So let's go back to the code. So what you need to do is basically create a new vector 3, and then what's going to happen is you want to scale the original size by this value, okay? So you actually need to save the previous size. So let's just do that first. So vector free prev size, previous size equals this. Okay. And now let's just call it prev size to be. And now each component here, I'm gonna scale by size. Now this will be wrong, and you'll see why in a second. Prev size y equals size times size. Prev size dot z times size. Okay. So what I did here is I grabbed the previous size of this object, and I'm just multiplying each of its size components, each xyz by the size value I'm getting for the slider. So now you're gonna see a weird bug. Let's play this. Okay, so painting is fine, nothing broke yet. Now let's play around with the size. So I'm clicking on the size, it's increasing. So far it looks like it's working. It's working, but something is wrong. It's not exactly correct. So you can see it's kind of exploding on me. That's how I would say. It's exploding on me. Anyone knows why? Any ideas? Yeah.
It's multiplying it by whatever the size was, like the previous.
Right. So basically here, if your size was, say, 2, and now you're multiplying it by, say, a value from 0 to 3. So say you're multiplying it by 3, it's going to be 6. But then if you change it a little bit more, it's going to multiply again and again and again and again, and that's where you get the explode. That's what you're trying to say.
Start multiplying the 6 by 3, and then you get like 18, and then it would start multiplying the 18.
Yeah. So it's
like exponentially increase.
Yeah. So we're going to get this. That's why we're getting this exploding effect. So there is a couple of ways around it. The easiest way, or one way I would suggest, is you to somehow remember the previous value of the slider. So let's kind of add that here. Private float previous scale. Okay, let's just put it like that. And what I want to do is I want to let's just set it to 1. So this has to be basically has to be 1. Well, let's just put it here. To match the default slider default initial slider value. Okay, it's just gonna get all the math to work. I'm gonna show you in a second. So it's like let's put it right here. Set size. Okay, so the idea is gonna divide this by the previous scale, and then you're gonna set this previous scale to be size. So let's just, before I explain why this is the way it will work, let's just see if it actually works, and I'm not like kind of messing around with you. Again, this may not be perfect, but let's just play around with it and see if it works. So this seems to work, and it's not exploding, which is good. Okay, so let me explain what I did. So what I'm doing is I'm instead of like kind of making everything explode, which is what you would get if you would not have this previous scale, you're basically you're basically remembering like whatever the previous scaling factor was. And say like you scaled something by 2 previously, and now you want to scale it by say 4. I know your slider goes from 1 to 4. What you would get without this division, you would get a scale of 8, right? Because it would be 2 times 4 will be 8, which is not, but you know your maximum scale should be 4, because that's what your slider allows you to do, right? So your slider is like, it gives you, let's say, a scale from 0.1 to 4. So your maximum scale should be whatever it is times 4, right? But in the previous code, we had like, what we, without this division, you could have scale times, if you set a value like, for example, like 2, it could be times 2, then times 3, then times 4. So you could theoretically get a scale of what is this, like 1224, like, which is not what you want. You actually want a maximum of scale 4. So this should be the maximum. Okay, so what this kind of math trickery here does, it basically remembers the previous selection you had for the slider, and then divides the current value you're getting by that to get the correct scale. Does that make sense what I'm saying? So for me, when I saw this, I think a couple of years ago, I was like, that how can that work? But it does work. So just think about it for like, a couple of minutes, and believe it's just math. You just have to do the math in your head, and you'll see that it actually works. Any questions? Okay, so now what I want you to do, I want you to take another 5 minutes and get this in your code, because that's like something that can really help you out with a lot of these kind of ops that control all the paintable objects at once. Okay, so just you can copy this, but most important thing is where's the code? That's not what I wanted. Yeah, most important thing is you need to kind of create the size slider and have the size slider have the right kind of values, something that makes sense, and then you can go up to speed with this code. Any questions? Think of like a piece of glass versus a hardwood or something like that. Now before we actually implement this, let's try to change it manually and try to figure out how to get that to work from there. So we have this cylinder again. Let's play around with that cylinder. Let's put some sort of color on it, maybe red. Let's make you red. Okay. And now let's look at this red color. So I'm looking actually at this material color, and there's all kinds of data here that is kind of important if you want to try to dig into that transparency and glow components. So first of all, here you can see there's like a shader type. So shader type is standard, but there's other shader types here. So what does this mean? This is basically in Unity, there's all kinds of ways that Unity can make color appear on your screen. And some of these are, say, more aligned with, say, mobile devices, for example. Some are more aligned with high visual effects. Some are just more aligned with textures. All kinds of shaders that don't really not even maybe make sense right now for you to know about. So here, the most important thing is you have this opaque versus transparent shader. So if it's transparent, you can actually get it to be transparent like this. So if it was in opaque mode, it would not get that effect. So again, let's just explain this again. So by default, when you create a new material, it comes with this standard shader where the rendering mode is opaque. Okay. So you actually need to get it to be transparent by kind of clicking here under this rendering mode, clicking here on transparent, and then it allows you to fiddle around with this transparency. So this is basically the alpha over here. If it's the same thing for RGB, you can just change the alpha and you can get it to be transparent or not. Any questions on this specific rendering mode, transparent versus opaque? So to do any kind of opaque kind of effect or versus transparent effect, as you see here, we actually need to kind of set the material to be transparent. Now this is something we need to do by script. So let's try to figure this out. First of all, let's create like a button and let's see if we can actually make it work. So let's see, where is our size button? So our size button is over here. And let's just zoom this on this. So I copied it and I am gonna reuse it. Let's put this here. And let's just call this opaque or transparency slider. Okay. And let's change the wording here to also be transparent. This should be the transparency label. Transparency. And let's just change the text here to actually say transparency. Or glow, whatever you know, whatever you want. Let's save this. Okay, so now let me just go over this code again. So if you remember, back in the day we had this function that can change color. It's called test.getComponentRenderer.material.color. Okay. Now, what you can do, you can reuse this to change the transparency. Let me show you. Let's try to reuse it to change the transparency. But to do that, we first of all need to, before we do anything interesting, we actually need to create a function to connect this slider to that transparency value. So let's go again to that slider. So this slider should basically go from 0 to 1. And let's just set it by default to be 0.5 as a default value for transparency, or this should be actually should say transparent. I'll figure this out there later. Transparent. And let's create a function here. Set size where public void set transparent float value. So now we need to connect this function to that slider again. How are we doing on time? Okay. So over here, painting, set transparent. Okay. Now this is, let's just try to, again, just reuse the code from before. So I'm going to copy this for each, because I'm going to go over each of these objects and set its color according to this value. So for each, okay. So child transform dot game object. So now what I want to do is I want to actually set its the color of the material here to be. I want to set its color to be determined by its transparency value to be determined by the slider. So I need to actually use this material color component. Let's do that. I'm just gonna game object material. So what I'm doing, I'm gonna first of all get the current material. I'm gonna grab the current material of the object, and I want to modify it to have this transparency value. So material color or set color. Let's see what we did there. I don't remember. So render. Okay, so we said just new color, blah blah blah. So we just have to give it a new color, and all should be good. Color is material of color. Okay, and we're just gonna set this material. Lots of kind of idiotic code, but necessary. New color. Now the new color should be the old color, but with the new transparency value. So let's see what color works with. Color, it accepts either RGB or RGBA, okay? So I can just use color R color.b color.g, and the value should be the current value. Okay, and that's just the transparency. Okay, something like this. So transparency value, let's just write this here, is from 0 to 1. 0 is transparent. 1 is opaque. Okay. Now this is not going to work. Let's just see that it doesn't work. So I'm painting these objects, and you can see it doesn't do anything. And I can actually debug. I can actually show you that it does reach that point in the code. I can actually add a debug kind of statement here, but it doesn't work. Debug log. This is something for you to check at home also. Like this does not work. Okay. And I can actually print this just to be fair. Here I'm painting and it doesn't work. I'm getting it to that point in the code, but it just refuses to do, it refuses to do anything. Does anyone know why? Why doesn't, I wanted to do this. This is what I wanted to do. Like, let's clear this. I wanted to like, okay, it doesn't work here too. So, yeah. So I wanted to do this, but it's not. Any ideas? Why not? Yeah.
You use the set color method for it? Like it doesn't let you directly just reference it.
So you're saying I should do
like material dot
material.
set color, and then you use that.
So you're saying like something like set color and then what?
And then you use the new color. You put new color in there.
Oh, okay.
The like the whole you have the material dot color equals, but you can just do material dot set color with that. I think that's a method.
So you're saying like something like this,
Yeah.
but it needs two arguments. It needs like a string name.
So you could like give it a name.
Okay. Test. Let's just try that. Let's try your approach.
I think that would work. I'm not sure.
Let's click on this. It doesn't work. Okay, so this is something for you to figure out at home. Why doesn't this work? Okay, we're gonna reveal the answer next time, but we have less than 15 minutes left. I want to start going over the clock. Okay, any questions? So just to summarize what we said is this doesn't work. For some reason, color refuses to change its transparency mode. A clue, I said a clue for this would be by default, you get like opaque shader mode, but you need a transparent shader to get it to be. So that's a clue. But the idea is you need to somehow set the material to be transparent for it to accept changes in the transparency in the alpha values. Otherwise, it doesn't work. Let me just type that down. So this does not work because by default materials in Unity are not transparent capable. To make a material transparent, you need to set it manually or by script. Okay, so you need to figure out how to set it by script. Now, any questions here? Okay, so let's start working on the clock, because you can see here a clock, and I really want to get that going so we have this up and running next time. So let's start on it. It's not going to be that difficult. So to do that, first of all, I want to create a new scene. So I have this scene. Let's just click here on the scene folders, right-click, and click on Create Scene. Okay, let's just call it the clock. Now you can do it a different way, but I'm just going to create a new scene just to be kind of have a fresh kind of start. Now, if you look at this clock, it is like a kind of a circle. And it has like these knobs. So these are kind of like cubes that are a bit stretched, and this circle could be like a cylinder that's rotated. So let's try to do it that way. And actually, I'm going to link like a guide on how to create this clock. I think it's already on the canvas. Anyway, let's create the clock. So right-click here, 3D object, cylinder. Now let's get this to be rotated so it looks kind of head towards us, like in this example. So let's get it to be rotated like that. Okay, and let's just make it so it's like at 0, 0, 0. So that makes kind of things easy for us to debug later. And let's focus on this cylinder. So now you can see the cylinder, and it's like it's okay. Let's just make it a bit skinny so it's kind of like a clock, so it's not that large. Now you can see it's really annoying to work on this in this kind of view. It kind of escapes me quickly. So in Unity, we have this 2D view option. I'm not sure you saw this before. So if you click on 2D, you can actually get like a very kind of technical engineering kind of focus to kind of manually edit your clock. And now let's just create these. So I have this base of the clock. Let's create the knobs here. So what I want to do is I want to create these knobs. Okay. So if I right-click here 3D object cube. Okay, so I want to resize this cube to be like a knob. Let's just change its material to be black-ish. Let's just create a new material. Create material here. Call it black, and just let's set it to be black, like that. Okay, and just assign it black. So my cylinder is hiding behind this cube. This cube is gigantic, and my cylinder is kind of behind it. Let's resize the cylinder to be kind of like this knob here. Let's resize the cube to be like a knob size and see if that looks good or not. So let's size it, smaller maybe, smaller, and maybe larger. I'm just kind of doing this by hand, so you see it's not super kind of great, but it does work. Maybe like this should be skinnier. Now this should be, and now it's kind of, you can't really see it, so let me just bring it to be a bit forward. Where are you? You should be at place 0, place 0. Okay, let's bring this cube a bit forward. Now you can see it. Okay. And let's just kind of double check that it looks about the right size as here. So it should be, so it's kind of like annoying to manually tune this, but this is a good thing for you to experience at least once. And this should be maybe 15, and this should be 0.5, 0.5. Yeah, that's about right. Okay, and let's just, okay, so one thing I can do, I can just manually create all of these knobs, you know, and like for each of that kind of clock kind of hour, like one for like 3 hours, 9 hours, whatever, but that's like super manual and slow. So I have a trick here. So the trick here is, let's just check that everything is fine before I do the trick. Okay, it's kind of hovering above, so I actually I wanna get it to be a bit inside. How do I get it to be inside? Yeah, I just want it to be a bit like that. Okay, so what I'm gonna do is I'm gonna parent this knob with like an empty, and then I'm gonna duplicate the empty, and then you're gonna see it's gonna work. So let's create an empty, and let's call this like an hour, and just make the empty 0 as usual, and I'm gonna parent this empty with the cylinder, which I'm gonna rename clock base. Okay, now I'm gonna take this cube and parent it with the hour. Okay. So let's see what happens now. If I duplicate the hour, then I get like this other cube, okay? But that's not the magic. The magic is, let's see if this works. Okay, that's the magic. So what I'm gonna do is here, like I'm just gonna duplicate these hours and rotate it to whatever I need. So I can just duplicate it and rotate it again, duplicate it, rotate it again. So let me just do that a couple of times and explain what happens here. Okay, so what happened here is I have this initial knob, and that knob is parented to an object that's centered over here. So what I can do is I can rotate it. If I have it rotate around that center, I can basically for free create additional knobs without actually having to draw them there and all of that. Uh, so the if you don't have it, like if you have this not like parented with that empty, and you just try to rotate like this, you will not get the same effect, because then it just rotates around itself. Okay, if you just have it like standalone here without parenting it to the center there, it will just rotate around itself every time you change its rotation. Okay, you see? But if I have it parented with the center, that means every time I rotate it, it will has to rotate around this guy. If this is its parent. That's how rotation works. It has to rotate around some sort of center point. So that's why I can just do that and just change these values as I see fit, like this. Okay, and then 330, and so on. And I can continue this kind of as, it's not like super interesting, but 60, 90, or whatever, 30, and so on. So I get all these knobs for free. Any questions on that? Okay, so what I want to do again is I'm not going to finish this clock now, but next time I'm going to finish it. And by next time, I also want to remind you to do the project 2 ideation. And just to remind you also that project 2 is out and waiting for your work. Also want to remind you, if you commit to something in ideation and submit something else, the TA will be very grumpy and he may not like your code. Okay? So if you commit to something, then try to do it. So next time we'll figure out